How many people here use Ruby in their day jobs? Okay. How many people here do not use Ruby in their day jobs? Awesome, awesome. You are the guys I really want to talk to. How many people here have been wanting to look at Ruby but have never really had a chance to do so? Yes, okay. Yes, that was my phone ring, the TARDIS. Okay. Good. So a handful of people are interested in Ruby. So when I submitted several ideas for talks here at Philly ETE, and they came back to me and they said, Jim, we really want to have a talk that gets people interested in using Ruby. And I thought, wow, I haven't done one of those in a long time. Most of my talks are done at like Ruby conferences. And by this time, you know, most people at Ruby conference have already decided to use Ruby. So this kind of talk isn't really useful there. So I said, great, I'd love to do this. And so this is a talk about why aren't you using Ruby. But before we get into that, we're going to have some fun. So I want to show you what we're playing with in our office. This is a video taken in the hallway of our office. Is it running? And why aren't we running? Oh, it's at the end. Ha, 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 ha. Okay, try this again. Okay, yes, this is better. I previewed it today. So what you're seeing here, right up there on the screen there, oops, is a flying quadcopter. And we are flying quadcopters in our office. This one is owned by Karen Meyer, and she's flying it using her iPhone. And there's Karen right there along the side, you can see here. She's running it. And what you don't realize, perhaps, is that it's being filmed by my quadcopter. So we have two quadcopters flying around. And she's in the light there. There it comes out. And what we're doing is Karen is trying to fly it around this open area in the atrium of our building. And I'm trying to do the thing where I point the camera and I kind of like follow her around like that, keeping the camera poised on her. Oops, a little trouble with the wall. We've discovered walls are very dangerous with these things. And all of a sudden she's going to begin to really move here. And zoom, there she goes. Whoa, I can't keep up. Oh, there we go. Okay, so we're having a lot of fun with this. I'm going to skip kind of towards the end because I want to show you what happens when you don't watch the battery level on your quadcopter. So there I'm filming, and we're getting a little wobbly there. And yeah, okay, and there we go. I just lost battery. But I tell you, these are AR Parrot drones. They're rather inexpensive quadcopters. You fly them with your iPhones. And we've just been having a great time with those things in the office. I kind of wanted to do that to kind of set the tone for this talk, because this talk is about fun, having fun with Ruby and things like that. So whenever anybody does a talk that tries to convince you to use something, they always focus on the features of whatever they're doing. And I think this is a mistake. I could talk a long time about all the awesome features of Ruby, about the block structure, about the expressiveness of Ruby, the fact that it's dynamic, the fact that you can do metaprogramming, and all these kinds of things, these really strong test culture in Ruby. I could go on and on and on about that stuff, but that is, although it's cool, that doesn't mean anything to you, because if you've never seen a block before, you're going to say, what use is that? I don't need blocks to do my programming. I've never used a block in my life. You're just crazy. So instead of talking about the features of the language, I've decided I'm going to talk about some of the benefits of using Ruby, and I'm going to illustrate that with a series of stories. I think I have 5 stories to tell you today. So rather than features, we're going to do that. So rather than call this talk, Why Aren't You Using Ruby?, this talk is better titled, Why I Use Ruby, because these are going to be very personal stories about things that I have done with Ruby that got me really excited about using the language. So without further ado, first story is about making the switch. It is the year 2000. And at the time, I was a C++ programmer and just getting into Java at the time. And I was using this language right here to do a lot of my tool support. You know, all those things that every developer needs to find all the header files and link them up together and compile your stuff and move things around and do mass renames on all your source files and all those little tools that every developer puts in his toolkit. And what language is this? Perl, yeah, Perl. You guys recognized it right away. I was using Perl to do some really, really cool stuff. And I had a lot of little Perl scripts that would go out and do really interesting things. Now, what I found out about Perl is that it's really great for doing those quick and dirty things. I could you know, jot off a script in Perl at the drop of a hat, and it would do something really powerful and really useful. But what I also found is that when I took that same script and then tried to expand it and generalize it, as soon as I tried to do something interesting like make a list of lists, or make a hash of lists, or anything with interesting data abstractions, Perl would fail on me. And I think the Perl people know this, because in their manuals, the tutorial about using lists of lists is called Perl LOL. I think that's indicative of something. I'm not sure what. So anyways, I was looking for a tool to do better abstractions for me. At the time, Python was available. And I took a really hard look at Python. The problem that I had with Python is that it was so radically different than the tools I was using at the time. Everything I did, I had to stop and I had to look it up in the manual. So I couldn't like just read a file and change some things in a file. I had to look up to see, oh, how do I read a file? How do I sense the end of file? And everything was just different, and I had to look up. You know, it was a pain to use. And in fact, I had tried 3 times to learn Python. And the first 2 attempts, I eventually gave up because I could just get things done faster in Perl. And I was on my 3rd attempt, and I said, I'm going to learn Python no matter what. I'm really going to conquer this language. I'm going to get over the barrier. I'm going to learn how to do these things, and then it won't be a problem anymore. I'll be able to do whatever I want to in the language, because I really, really, really wanted something with good abstractions. So in the middle of my 3rd attempt to learn Python, I was reading an email list, and this fellow right here posted, I think it was the Extreme Programming mailing list, because in 2000, Extreme Programming was really hot at the time. So I was reading that list, and Dave Thomas posted an email message that said, oh, we just discovered this little language called Ruby. And we really like it, and you might too. And here's a link to the Ruby, where you can download Ruby and use it. And I had just got done reading The Pragmatic Programmer. How many people have not read this book? Okay, if you have your hands in the air, you have homework assignment right now. Because this is the awesomest book, and it still is, I think, still relevant even here 10 years later. So I just finished the book. I thought, well, if Dave Thomas is recommending this thing called Ruby, and I love the advice he gave in this book, it's worth taking a look at Ruby. So I downloaded Ruby. I built it on my workstation. I think I was using an Silicon Graphics Unix workstation at the time. I built it to run on there. I started playing around with it. And in 2 days, from the point I received the email, and in 2 days, I entirely stopped writing any new Perl programs. Everything thereafter was done entirely in Ruby. I switched entirely in 2 days, and I felt as productive in Ruby as I ever did in Perl. And all of a sudden, I had powerful data abstractions that I could use to do that. The switch was entirely painless to me. Now, I don't know if it will be the same for you or not. Ruby just matched the way I thought, and though my background in C++ and Java and Perl, and I had a smattering of Smalltalk. I was using Eiffel at the time as well. All those things kind of came together, and there's a little bit of all of that in Ruby. So, summary. Ruby has what they call the principle of least surprise. If you have a problem and you think, how would I solve that? And you try it out. Oh, I bet there's something like this, and you call this kind of method on it. And by golly, most of the time, that kind of thinking works. It's surprising, but it does what you think it should. It has great data abstractions. It's got classes. It's got real classes that you can manipulate. It is very, very, very object-oriented. I would say that Ruby is one of the most object-oriented languages out there. It ranks right up there with Smalltalk. In fact, there's a quote from Kent Beck, who says that he always knew that Smalltalk would eventually win. He just didn't know it would be called Ruby. So its object orientation model is really, really similar to Smalltalk. So if you like Smalltalk, you will see some really powerful things in Ruby. And it's, like I say, I switched over in 2 days. I teach a Rails course these days. And we have people coming in to learn Rails, a web framework, who do not know Ruby. And at the end of 3 days, they are productive in writing Ruby code to do their Rails framework. Now, it's better if you know a little bit of Ruby, but people can come in and pick up just enough of the language to get really constructive things done. It's really that great. Okay, that's story number 1. Story number 2, it's a rescue story. This is a true story. Actually, all my stories here today are true, but this one in particular I want to stress is very true. And at the time, this is soon after I started using Ruby, and I started writing all my tool sets now in Ruby. And I was working at a major financial institute where we did large financial transactions of various sorts, retirement funds, stock buying, employee stock options, all those kinds of things were handled by this company. And I had written a lot of little Ruby scripts to go and read the database, dump out data in the database, to kind of massage the data. And the workflow that we had established at this company worked something like this. Every single piece of mail that got sent to this large company that was all over the states, everywhere, every single bit of mail came into one facility in Covington, Kentucky. And it was scanned in a scanner. The paper from the mail was scanned into a scanner. When that happened, the scanner would take the image that it scanned, stick it in a database, and generate an event that contained a reference to the image in the database. And it would send this out. It would publish this event out to see who would be interested in it. Well, then it would go to a barcode reader program, and the barcode reader would take the event and process that, and it would look at the image and say, oh, look, here's barcode data on this image. I'm going to decode the barcode and add it to the metadata with this event. Then it will republish the event with barcode data, and then the checkbox checker will pick that up, and it will scan the image looking for checkboxes that have been checked or not checked, and it will add that information to the event, and it will republish that, and then it will go to a place that will read handwritten characters and do kind of an OCR on that, and then run it through a workstation where someone can double check to see that the automatically OCR'd characters were entered correctly, and then it'll publish a new event. And eventually this event gets populated with more and more and more data from the form, and then will be routed to whatever part of the company handles stock options, or whatever part of the company handles retirement plans, whatever part of the company handles whatever we're doing. So it's kind of a workflow thing. And this is the front end that added data to the image as it was scanned. Now, this is really interesting because this was designed in the days where everybody sent paper mail all over the place. In modern days, we use what? Faxes. This is really cutting edge technology here. So when they added the fax system to this, they would take the faxes, they would print them out, and then they would scan them in the scanner. Someone had the bright idea, you know, we've already got the image in a fax. There's email to fax bridges. Let's go and get one of those, and let's have the system send us an email containing the image of the fax. And so the fax processor would receive a fax. He would create an event with a form that has the image on it, and then it would inject it into the same workflow as everything else. And this is a great idea because printing out a fax and rescanning it was really, really iffy as far as image quality terms. This worked much, much better. So that's the setup for the story. I was sitting at my desk one day, coding away in Java, maybe perusing the database a little bit with some of my Ruby scripts. And I noticed that there was a lot of buzz going on around the cubicle. And people were walking back and forth, and people were huddling in cubicles and talking. And I could tell something was up, but no one came to me right away. And eventually, my boss came by with another one of the developers, and they said, Jim, you're pretty good at Ruby, right? And I said, yeah. At this point, several other people have been using Ruby in the group. I've been evangelizing the group. But they knew that I was using Ruby quite heavily. So they came to me and says, well, we have a problem. You see, somehow, for some reason, the fax process is dropping events. I don't remember the exact reason it was dropping it, whether there was an exception in the fax processor or what. But it was not getting the events and sending them into the workflow like it should. And this had been going on for some time. Now, you got to realize, this seems like, oh, you're not getting faxes. Remember, this is a major financial institution. And there are stock purchase orders that come in on the fax. And from the moment they receive that fax, they have, I think it was like 3 hours or something like that to actually perform the transaction. If they did not perform that transaction within that amount of time, then they are liable for the difference in the stock price between the closing of that 3-hour period and what they eventually got. So if the stock price had gone up, they would be liable for the difference of that purchase. And that's a potential of millions and millions of dollars that they could lose by the fact they're not processing these orders quite fast enough. So there was a lot of panic involved in this. Fortunately, the fax program actually produced a log file. And that log file had the ID of the image in the database. It had the time the fax arrived. It had enough information in it that, in theory, someone could take that information and reproduce the event that was dropped. And that was the job they assigned me. They had me write a Ruby script that read the log file, found those events that were missing between this time and that time, and then it would rebuild the event by parsing out the data in the log file and publish the event onto the workflow and send the data on through. And I don't know, it took me less than an hour, probably about half an hour to do this. And we saved the company millions and millions of dollars. Ruby was a hero. I would like to say they gave me a percentage of the millions of dollars they saved, but that did not happen. But I was quite pleased to actually help them out. So that was a good story. So here, Ruby was a savior. It was a really quick solution. We're able to parse the log file, pull out the details, and publish events in a timely manner. This just would not have been possible with using the Java technology that we had at the time. It was just too cumbersome to do that kind of thing. And Ruby stepped right up and really handled it. Now, I want to say I was not the only hero in the story. There were lots of other developers working in other pieces, why the fax system failed, how to fix it, how to identify the pieces that were missing. I had one small piece of that whole operation, but Ruby was a very, very critical piece of that solution. So that was cool. Next story, making a surprise. I like building things. I think building things is fun. This is a picture of a gal in Bend, Oregon, and she is building a fretboard for a guitar. You can see two guitar necks laying out there on the table. She's got one in her hand, and she's actually cutting the channels there and filling out the channels where the frets will be placed on that guitar. This is at the Breedlove Guitar Factory in Bend, Oregon. And I picked this picture because I have a Breedlove guitar. And this is my excuse to show it on screen. I love this guitar. This is an awesome guitar. But building things, that's the theme of this one. So I want to talk about a time I was working on building something. I was pairing with a friend at work. His name was Ryan. And Ryan and I were trying to build a rather largish Java system using Make. I don't know why we weren't using Ant. Ant had been out at that time, but it was early enough in the history of Java that Ant had only been out a short time and not everybody had adopted it yet. And we were still using Make to do a lot of our build process at the time. And he and I were trying to get something to happen, and I don't recall the exact details, but it was just a little bit too dynamic for Make to be able to do. Are people familiar with Make? Who's not? If you're not familiar with Make, raise your hand. Okay, so Make is a Unix tool that you say, build this thing, and it will compile the files, it will link the files, it will generate an executable, and it will do all those based upon declared dependencies in your code. we were trying to get make to do something that was just a little bit too dynamic for it. And I was really, really frustrated. You can see I was pulling my hair out. And I turned to Ryan and I said, Ryan, wouldn't it be great if make were written in Ruby? And Ryan says, Jim, that's an awesome idea. I have no idea what you mean. So I turned around to the whiteboard in my office and I scribbled down something that looked a little bit like this. I said you would have a task function that you gave it the name of a task, and then you would say do n, this is a block in Ruby, and then the block would contain code that would run. So whenever I wanted to do the compile task, it would grab the source files and compile them. And there would be ways of specifying dependencies between all these tasks so they would all run together, essentially doing what make would do. But since we have a full language available to do the do end block here, we could do anything we want to, and it would be a really, really, really powerful system. And Ryan agreed with that. He thought it was an awesome idea. So we talked about it for a little bit, and we decided that even though it'd be a cool idea, no one would ever do it. I mean, I'd have to reproduce the entire make program just to get it in Ruby and parse all the files and figure out how the dependencies works and all this stuff. And we just decided, oh, that'd be too much work. You'd be crazy to try and do that. So Ryan goes back to his desk, and I started thinking, this is dangerous, leaving me alone to think. I thought, well, how hard could it possibly be? I mean, you would have to have a task method, and it would take a name and some dependencies and an action. It'd store them off somewhere, and then it would just walk the tree of dependencies and invoke it. I thought, well, that can't be that hard. So here's an example process. If you were to make mac and cheese, just as an example. Your top-level task might be to make mac and cheese here, but this task depends upon doing 3 other things first. You have to boil water, you have to buy pasta, and you have to buy cheese. Well, it turns out that if you're going to do these 3 things, the boil water kind of depends upon you boiling the pasta and cheese first, because you don't want to start the water, then go to the store. So there's a dependency between boil water and buying pasta and cheese. So these things happen first. And before you buy pasta and cheese, you need to go to the store so you can therefore buy them. So here's a little set of 5 tasks with dependencies between them. And if I were to encode this in a dependency file, it might look something like this. And this is just Ruby code. Here's the task. Here's the name of the task. Here's a list of things that must be done before you make the mac and cheese. You need to boil the water, buy the cheese, buy the pasta. And then for our do block, we're just going to print out a message, okay? Here's boiling water. You must buy pasta and buy cheese first. In order to buy pasta, you must go to the store first, and likewise for cheese. And here's the go-to store. There are no dependencies on this one. You just go to the store. So what would it take to write some Ruby code to execute these things in a dependency manner? Let's find out. So here's a directory. I have the tasks file there, and that's just what you saw on the screen a moment ago. And I also have something out here called microrake that is absolutely empty. So we're going to go and edit microrake, and we're going to write rake here as part of this live demo. Okay, so I'm going to start at the end of the program and work my way to the beginning of the program. So what I want to do is be able to have a command line. I want to be able to say this: Ruby microrake make mac and cheese. And this will do nothing because microrake is empty, but what I want it to do is to start doing all the processes that you need to do to make the mac and cheese. So what I want to do is go through the list of arguments. There we go. I don't know what I was saying. So I want to go through the list of arguments, and for each one, I'm going to grab an individual argument. So this will be a name of a task. So I'm going to assume I have a tasks hash, global tasks hash set up. I will look up the task in that hash by the argument name. And then I am going to invoke that task so it executes an end. That's the end of my loop. So this will loop through each argument on the command line, look up a task for that argument, and invoke it. Okay, so that's the last thing I do in the program. So I'm going to need a global hash array, or global hash, and then I'm going to need a method called task that will take a name, a list of dependencies, and an action. And I want to make sure the dependencies are optional, so I'm going to tell it if you don't provide dependencies, then just have an empty list of dependencies. And then in here, I'm going to create a new object called task, task.new. You'll give it the name, you give it the list of dependencies, and you'll give it the action. And I'm going to take that newly created task and assign it into the tasks array under the name that I just passed in. So this will populate our global task array with task objects. Cool. Now at this point, I should be able to say require the dot task list here. This task list is the one that we saw up on the screen a moment ago. And since I just defined this method here, all these, when I require it, it will load all those task definitions up for me. All right, so now all I have to do is create a class called task. And come on, there we go. Okay, it's going to need a constructor that takes a name, dependencies, and an action and stores them off for me. We're going to give it a method called execute. And execute is just going to take the action, which is a block, and call the block. So by calling the block that's passed into the task object, it's going to actually do the puts commands that are defined, okay? And since I only want tasks to execute once, like I only want to go to the store one time to buy both mac and cheese, I'm going to have a little flag called already run. I'm going to set that to true so I can track the fact that this particular task has already been executed. All right, I think I'm ready to write invoke. First thing, if the task is already run, I don't have anything to do. Okay, that was easy. The next thing I want to do is make sure that all the dependencies for this particular task have been invoked. So I'll get my list of dependencies. For each one of those, I want to say something like dep invoke. But that's not quite right because these dependencies are just names, they're just strings. So I need to look up the task object corresponding to that string, to that name. Fortunately, I have a global variable called tasks that I can look it up in. Okay, so that line makes sure that all my dependencies are run. And finally, I just need to execute this particular task. That's 28 lines of code. Voila. In practice, that takes about 3 or 4 minutes to write all that out. So in 3 or 4 minutes, we reproduced a good fraction of the functionality of make using Ruby. And we did that by specifying our dependency files as real Ruby programs and not parsing things. And I did this, actually. I sat down and I did this. And I emailed Ryan, and then I ran over his desk and I said, Ryan, check your email. And I showed him essentially this code right here. It was a little more filled out. I had some more error checking in it, some other things going on in case task names weren't found. I said, Ryan, see what we did here. And we just marveled at this code. It took about 15 or 20 minutes or maybe half an hour. I don't remember now exactly. But it was really, under half an hour, I had the very first version of Rake up and running. And we were looking at this. And we decided this is a really cool hack. But the astute among you will notice a difference between what I did and what make does. Make does something else. If you have 2 files, and I want to build like an object file out of a source file, make will compare the timestamps in the 2 files and say, oh, look, this object file has not been changed since we changed the source. So therefore, it's up to date. So it will not recompile it. It does timestamp checking on file dependencies, so it doesn't do that. So I was saying to Ryan, yeah, we don't do the file timestamp checking, and that would be really hard to use, and no one would ever do that. They'd be crazy to try, and blah, blah, blah. And I went back to my desk, and I sat down, and I thought. And what I did, I took the task class. I added a method called needed. Do I need to invoke this task? In the task class, it's always return true, because you always invoke a task. Then I created a file task that derived from task that overrode needed, that checked the timestamps between the original file and the dependency file, and I was done. I had something that was essentially about 95% of make right there in just a very few lines of code. So that is the, Ryan told me then, I got the perfect name for this. We need to call it rake. So Ryan named it. Rake is Ruby's make, and that's where rake come from. So if you ever do any Rails programming at all, we use rake all the time, and that was the beginning of that story right there. So 28 lines of code. That's amazing. It took about half an hour of effort for the first version. It was the core rake engine. That engine is still there. It still does about the same thing. We've done a lot of things since then. We now have parallelization going on. We can run tasks in parallel. We have promises in there and futures. We have a really nice file list interface, so you can manipulate lists of files quite easily. So there's a lot more to rake now than just the core. But that is it. That's what rake does at the bottom of the thing. So cool. That's the story of rake. Oh, I just got this email today. I had to share it. I get these emails all the time. People ask me for quotes on power rakes and sand flea rakes, and here's a root rake. I don't even know what a root rake is. So I guess something that pulls up roots somehow. Is it a powered thing or not? I don't know. Power rakes are cool. They're like big tractors that grind up dirt. But yeah, this is hilarious. I get this kind of stuff all the time, and I had to share that one. Okay. Yes?
Can you just highlight what in Ruby made it possible to do rake so quickly?
Yeah, so what made it possible to do it so easily is really high order abstractions. I was able to talk about lists of things and iterating over lists very easily at a very high level. It had a very expressive block syntax for capturing actions. You could do this in about any language except for the fact that capturing the actions in a do-end block is difficult in most cases. I know there's a version of Python that does make-like stuff, and its syntax is way more convoluted than what this is. It's the ability to capture those anonymous functions really easily and pass them around. And in a easy-to-use syntax, it's very natural, is what makes Ruby especially good for that kind of thing. And we're going to take advantage of that over and over and over again in some of the other examples we see here. Okay. This one is called Beautiful Testing, or maybe a better test, is designed by Conference. I am really big into testing my code. I'm a big fan of doing, TDD, unit testing, acceptance testing. And I really want my tests to be expressive. And I've worked really hard on writing tests that are readable, but yet non-brittle, that don't break when you do a lot of refactoring. And that's kind of the kick I'm on right now. And so about 4 years ago, at a conference called the Ruby Hoedown. Anybody ever go to one of the Hoedowns? Awesome conference. They're really lightweight, and in that there's not a lot of planning involved. People just kind of show up and talk. They're free, so they're easy to get to, and they're generally held in Nashville, Tennessee. So me living in Cincinnati means that I can drive down to that. And in 2009, a bunch of us edge casers got together, and we all drove down to the Hoedown. This is a group of people here. Now, you see palm trees there, and you're probably wondering what palm trees are doing in Nashville, Tennessee. This is the Grand Ole Opry Hotel, and this is all indoors. It is a fancy hotel. So this is how they have a free conference. The conference is free, but to stay in the hotel is really expensive. But here we're all sitting around. This is actually at lunch. But during the conference itself, since we went down as a group, we tended to just kind of sit together as a group. And we were in the back of the room around a round table listening to a talk on Cucumber. And Cucumber is a testing tool for acceptance level testing to drive your web applications using a very high level domain-like language. You would say, given you're on this particular page, when you click on the login button, then you go to the login page. You know, things like that is how you save it. But the structure of the test in Cucumber is given, when, and then. And I really like that way of expressing a test. I think that's an awesome way to write your test. Given the setup condition, when you run this code, then this is the things you tend to expect out of that. I was looking for a way to express that in unit tests. I've been kind of structuring my unit tests at the time around those lines anyways, but I didn't have a language to make it very clear that's what I was doing. So I took a notebook. This is back in the days when I still used paper and pencil. And I jotted down on the notebook something that looked a little bit like this, and I started passing it around the table. I didn't explain it. I just said, if you saw this in code, would you know what this meant? And we iterated on this a while. People gave me some suggestions. We refined it a little bit. But I was really looking for a way to, in Ruby, directly in Ruby, not going through Cucumber, but in just using pure Ruby, be able to express, given these things, when you do that, then these things happen. This actually, well, my boss first told me, Jim, we really don't need another testing framework in Ruby, because at that time the test unit versus RSpec thing was going wild and people were arguing that. And there was mini-test, and there was some other test frameworks as well. And Joe didn't think we really needed something else. I said, no, Joe, I'm just playing with ideas. I'm never really going to implement this. I lied. A while later, I actually implemented something that looked very much like that on top of test unit. And it looked like this. And this is still out there on GitHub if you want to take a look at it. I don't recommend using it. It's kind of got some older ideas in it. I like the newer versions better. But this, I really like this because I'm saying, okay, here we're talking about a stack. And here's some invariants. These are things that are always true about a stack. A stack's depth is always greater than or equal to 0, no matter what. And if the stack is empty, then the depth is 0. And that's kind of a if and only if type of condition. So we could specify invariants that were always true about stacks. And when we had an empty stack, then this depth is 0. And I just really like the way this read. For the most part, I was still unhappy kind of with this given thing. The fact I had to say given and I had to write a setup method by name seemed kind of awkward to me. But it wasn't bad. And I played around with this for a while, but it never really went anything. Next conference. This was 2010. I think it was a year later, maybe 2 years later. I forget exactly the sequence here. But I was at the Ruby Nation conference in DC, and a fellow there named John Larkowski was giving a talk called Pure RSpec. Now, I had been a test unit guy from day one. I've been using test unit. I liked test unit. I wrote all my tests in test unit, and those RSpec guys, they were just, you know, you couldn't trust them. But he was doing this talk on pure RSpec, and he got to this slide right here, and all of a sudden a light bulb went off in my head. And he said, RSpec has this construct called a let construct. And you can say, let a blog post be this. And what this would really expand to is something like this. It defined a method called blog post that would lazy initialize an instance variable called blog post with whatever was there in the block. See, here's another instance of blocks playing an important aspect of Ruby. And so it captured this, ran the block, created it, and captured it and saying, and would only ever do it the first time you mentioned blog post in a test. And then it would recreate that every time you ran another test. So this test would create a blog post, this test would create a blog post, and it really read really nicely. You got rid of all those @ signs in all your tests. Things were lazy initialized, so if you didn't use them, they didn't cost anything to do. And it was kind of awesome. And the best thing I liked about this is the fact, the way it interacted with the nested test structures of RSpec. In RSpec, you can have describe and context blocks that nest within each other. And in each block, you can have a let here and a let here. This outer let defines the contents to be blah. This inner let, in this context with empty contents, you can say, let it be an empty string. And this one actually overrides the outer one because what RSpec does is something like this. So the outer describe is an example. The inner context is another example that inherits from example 1. So all the methods defined up here are also available down here, but since it inherits, if you redefine something, you override that in the child class. So it's easy to override stuff in the nested context. So I could set up a default value and then write a lot of little variations, with an empty contents, with a really long contents, with invalid contents, with this kind of contents, and write a bunch of specifications upon varying the different kinds of contents that might be in a blog post. I thought that was really cool. So with that in mind, I revisited my given when then idea, and I came up with this. We take let and we just rename it to given, because RSpec already did exactly what I wanted it to do. So these kinds of given a stack, given initial contents like this, and then given that we take the initial contents and stuff it into the stack. So this is kind of like a before block here. This given is more like a before block. I still have invariance here. And then I have individual contents. So with an empty stack, here's some tests. With a stack with one item, here's some tests. With a stack with several items, here's some tests. And we can expand those. Here's the empty stack set of tests. So given the initial contents are empty, then the stack depth is 0. Now notice, if you're used to RSpec, you're used to seeing something dot should something else. Notice there are no dot shoulds here. In RSpec, given the then tests the return value of this. And if it's true, we're OK. If it's false, the test will fail. So we got rid of all the shoulds just about everywhere. So with an empty stack, when you're pushing, so here's the code under test. This is the code I'm testing, and I know that because it's in a when block. So I'm very clearly expressing what the setup is, what the code I'm testing is, and what my expectations are for each one of these tests. And my tests all of a sudden became very, very clear. They also become very short because I can reuse some initial setup and only override the pieces that change and vary from 1 to 1. And it tends to write really clear tests. I like this one too. The result should have failed. So we stack it, we pop an empty stack. So remember, the stack is empty. When I pop it, I save the result. That is an exception. I actually store off the exception, and I can assert that it is an exception right here. So we get a stack underflow error with the word empty in the stack message, in the error message. Here is with several items. Yeah, so again, just straight equals, no shoulds in there. And I really like the way that looks. How about you guys? Do you like that? Give this a try. If you like this, give this a try. It's a fairly lightweight library. Works with RSpec. You can have regular RSpec tests and mix in some when then, so you don't have to convert everything all at once. But when you use it, I think it reads really nicely. The other nice thing about this is that when you do have an error, suppose we wrote 2 here rather than 1 and then ran the test, you would get an error message that looked like this. So stack with several items when popping. So we got several items in the stack when we're popping. The stack depth should be the original depth minus 2. I changed that. It should be a 1. I changed it to 2 to get an error. The expression failed. It gives you a line number. It said we expected 1 to equal 0. And you say, OK, well, here's stack depth equals original depth minus 2. That's false. Well, why is it false? Well, stack depth is 1. OK. The stack itself is this object. The original depth is minus 2, which is 0. The original depth itself is 2. So you essentially take the sub-expressions apart and print out the value of all the sub-expressions in the failing expression. And I really like this for error messages. I think this allows you to debug things very easily without writing a lot of special matchers that you would otherwise write in RSpec. It leaves your code very clear. You avoid the faux English problem of RSpec. Faux English is where you write code that it looks like it should be English, but the grammar is a little bit stilted because of it's not real English. And I really like that. So that's RSpec given. Key here is that sometimes, rake happened in half an hour. RSpec given happened over the course of 4 years. And it's a very mature product now, and a lot of people are using it, but it took a while to get to the right spot. And it took a while for some of those ideas to percolate, but I was able to experiment and try different things and publish it and get feedback, and I really like that about Ruby, how malleable it is, that I can take an idea and just continue to change it and refine it till I get what I want out of that. So again, another instance of using blocks to good use in Ruby. Let's see how we're doing on time. Yeah, okay. They told me this morning that I'm right before lunch. And they say, talk as long as you want because we want to stagger people going to lunch. So I said, I can go right up to 12:30 and maybe just a little bit past. So just hang on. I'm not going to hold you real long. You'll still get food, but they're trying to stagger the amount of people going there. So don't panic when we get to 12:30 and I'm still talking. Now, this is another story. I just added this one this morning because I wanted to share another really cool idea that happened in Ruby. Have you heard this quote? Jamie Zawinski. Jamie Zawinski is the guy who worked on the Mozilla browser way back when. He worked on Lucid Emacs back in the day as well. He violently protests that he had nothing to do with the blink tag in early Mosaic, so there you have it. Jamie Zawinski. I love that. When you have a problem, you solve it with regular expressions, all of a sudden you have two problems. I just saw this on Twitter the other day. I'm not sure it works like that. So how many people here are not familiar with regular expressions? Oh, awesome. We got a whole room of regular expression experts. This is awesome. How many problems do we have now? So here's a quick little example of a regular expression. I'll go through it. You know, if your regular expression foo is a little bit stale, I'll go through it real quickly what we're doing. This is just a simple expression to match some simple emails. It's probably not even a very good matcher, but it's just for demonstration purposes. So here we have two sections that match alphanumerics plus a couple extra characters as well. So it matches lowercase a through z, uppercase a through z, 0 through 9, an underscore, a period, and a dash. And that will match any single character in that group of characters. Then here we add a plus sign to it, and that says match one or more times. We put parentheses around each of those, and it says remember when you do a match, remember the sub-expression that matched this particular piece of the regular expression. We then have match the beginning and the ending of a line. So then we can run the match. Okay, yeah. So beginning and ending of a line, not a string. This goofs me up every single time. So that's probably an error. I probably wanted to match the beginning and end of the string, not the beginning and end of a line, because this could mean that a regular expression with multiple lines, it would still work if one line was a good match. So then when you run the match, you get back a match data object, and then you can ask the match data for sub 1. You get the first sub match, and sub 2 gives you the second sub match. So you can pull pieces of the thing out of that. And that's okay. And if you're used to regular expressions, that's actually not a really big problem. But let me throw this up here for you. What do you think of this? So here, this is more verbose. Yes, it is more verbose. But I think you need less specialized knowledge to kind of piece through what this is. So here, we're saying we have a regular expression, and it will match any of these categories, A through Z, cap A through Z, 0 through 9, or the characters underscore, period, or dash. And it will match it one or more times. And we're going to save that in something called a word regular expression. Now that we've captured it in a variable, we can reuse this in a larger expression. So here we're saying, okay, we got two places we want to match a word. When we match, we want to capture that, and when we capture it, let's capture it in a name. So we have the name and the name host. We're going to put everything together. We're going to concatenate those three things together, the word, the @ sign, and another word. And then the whole thing must match the entire string. Notice I got it right this time because I'm saying all. And that automatically puts the right end of string matchers on it, which I never remember when I'm doing raw regular expressions. We then use the match method just like we did before, and we get a result, and then we can pull out the name and the host by name rather than trying to remember, oh, is the first expression or the second expression? This is awesome. I can now build dynamically regular expressions programmatically, and I can build them up piecemeal. And the only other way to do this is to take strings and interpolate strings and then build up a regular expression there. And that's error-prone and tedious. So this is kind of a nice little library for expressing regular expressions in a rather readable format, a little bit verbose, but rather readable. And notice there's no special escaping. I didn't have to do any special characters in any of these things. I just put them together, and the regular expressions are really expressions. I can say expression plus another expression, and it concatenates them together. It works like this. There is in this library a class called REXP, REXP. And you initialize it with a string that represents a regular expression, a precedence level, and you have to do that so it knows when to add parentheses to these things or not. You give it a list of named keys of sub-expressions that you want to match against, and then there's options like ignore, case, handle multi-lines. There's a couple options on that you can pass in. And then, there's a lot of this code I just left out, but here's the key. You can define operators in Ruby. So when I have a REXP object and a REXP object and say plus between them, that plus is a method that gets called on the REXP object right here. And it takes those two strings, the self and the other, encodes them, and concatenates them together and builds a new regular expression out of the concatenated version. There's a method with a vertical bar to OR alternatives together. You can parenthesize these. You have the one or more methods on it that will add a plus. You have many method that'll add a star to this, so it'll build up whatever regular expression you need and do all the internal handling of it like that. So that's kind of a cool thing. Now you say, well, what uses that? Because regular expressions are pretty straightforward anyways. And truth is, I haven't used this library a whole lot myself. It was kind of an experiment to see how expressive I could make it. But the technique is useful in other domains. If you've done anything with Rails recently, you're familiar with the AREL library, active relations. And it takes relation semantics and builds relation expressions out of them that you can concatenate and tie together like this. So if you have users where the username is equal to Amy, and you project that here on the user's ID, you get this SQL out of this. So this is a set of expressions that internally build up SQL statements, and you can combine these and have them create one and then add more methods to it and programmatically create these and manipulate them rather than taking SQL bits and sticking them together, which is very error prone. This is a much easier process to use. And this is an awesome bit of Rails technology that uses much the same thing that I did with the RE library. So that turns out to have very, very, very practical use in your everyday use. So regular expressions, simplify constructions. And the key is, you want to make your code as expressive as possible in the problem domain you're working in. And Ruby really lets you do that. We saw it happen with build dependencies. We saw it happen with regular expressions. It's really easy to take Ruby and to write a library that succinctly captures domain knowledge in a very concise and very expressive way. One more story. And we're at 12:30. You'll like this story, so you won't mind going to lunch just a little bit late, because it involves flying robots. You saw my video at the beginning of the talk here, the AR drone, Parrot AR drone quadcopter. It has two cameras on it, a forward-facing camera and a downward-facing camera. It has video recording. You can either do it remotely on your iPad, or you can record directly on a USB stick inside the drone itself. It's got gyroscopes so it can tell when it tilts. It has accelerometers so it can tell when it moves. It has an ultrasound sensor that points downward so it can tell how high off the ground it is. It also has a barometric pressure sensor so that when it goes above 9 meters and the ultrasound no longer works, it can tell how high it is through a pressure sensor. It's got an ARM processor on it running Linux. And yes, you can telnet onto your drone. I have actually loaded a couple shell scripts onto my drone, and so it's a couple bits heavier than a standard drone. It's got Wi-Fi on it. It creates its own Wi-Fi hotspot, so you just connect up to it and you talk directly to it. So the big thing I really like about this drone that got me excited about getting them is the fact that it comes with an SDK. You can go to their website and download a complete SDK containing libraries, documents describing how to control an AR drone programmatically. And that's what got me really interested in this. So it works like this. There are 3 or 4, I think there's a configuration data stream here that I don't have listed, but there's 3 major ones that I'm primarily interested in. There is a command stream where we send commands to the drone to tell it to do things. It has navigation data coming back from the drone. It also has a video stream coming back from the drone that you can record the video with. The command stream is really simple. It's just lines of text that look like this. AT star, and then the name of the command, ref, pcommand, and config are the 3 here. Every command has a sequence number that must be incremented every time you send it a new command. That's how the drone tells that your program, your controlling program is alive and sending good data by the fact it keeps incrementing the sequence number. The ref command has a set of flags that tell it to land, to take off, to do an emergency landing, to do this, do that. So a bunch of bit flags essentially in the ref command. The P command sends things like roll, pitch, up and down acceleration, and yaw, which is back and forth like that. So you can send all 4 things to the drone just by using the PCMD command. The config command allows you to send configuration commands like tell it to flash its lights in a particular pattern, or to look for a particular pattern for video targeting. Yes, it does video targeting. It has a forward-facing camera, and when it sees particular patterns of color, it notices those and puts information about those in the data stream, not the video stream, but the data stream. So let's talk about how you might control it. Here is a simple program written in Ruby that controls a drone. Creates a drone object, tells it to start. We take off, wait 5 seconds for it to get up to hovering height. Then turns right for a second, sleeps 5, and then turns left for a second and sleeps another 5, and then hovers and then lands. A hover and then land, and then it stops, shuts down the interface. Take off, hover, turn right, sleeps a second, then it turns right for 5 seconds. Then it lands. Okay, there we go. So there you go, programmatic control of your drone in Ruby. Here's another program. Take off, sleep 5 seconds, then 2 times. Here's a loop. Turn left, go left, 0.3, sleep a second, go right, 0.3, and sleep a second, then it'll hover, and then it'll land. This is how fast you go left and how fast you go right. The first time I tried this, I was in the interactive IRB session. I said, drone, right, 1. And it went full tilt, full throttle, bam, right into the wall. Because I had no way to stop it without typing drone.stop, and I was way too slow for that. 0.3 is a much better speed. So here, you see the program I got on the screen. You can see my cursor at the bottom. I'm going to hit return. It'll be 5 seconds before the program starts. So I got 5 seconds to run across the office. This is me running. Take off. Right, left, hover, land. So that's basic control. Sending it commands is easy. However, the data stream coming back is much more difficult. It's a binary encoded stream with a fixed length header and variable length sections that are optional. So you got a fixed length header, then you have nav data and vision detection data and other things in here that are variable length. And the variable length stuff looks like this. It starts with a 16-bit integer that is a tag that tells what kind of option it is. It's got a 16-bit size that tells you how many bytes are in this particular section, so you have to walk through that and parse it. Then you've got things like control state, battery percentage left, theta, phi, and psi, that's roll, pitch, yaw. Altitude is all there. And these things are floats, and they're encoded in a bizarre way. They're integers encoded into a, that you need to interpret as a floating point number. Weird. So to decode that data in Ruby, I have to do this. Ruby has an unpack command where you give it a binary buffer, and then you give it a bunch of format flags. Lowercase v is a 16-bit integer. Uppercase v is a 32-bit integer. Least significant bit first. And then once I get that, then I know that in position 4, 5, and 6 in that, they are floating point numbers, so I have to decode the floating point numbers like that, and it's a pain. I don't want to write code like this. This is hard to write. This is hard to maintain. And I'm not even sure it's right. Did I get all the formats in the right position? Do I have these numbers right? So I did this. I wrote this. This is Ruby code. Look at this Ruby code and compare it to the C code here. uint32t control state. uint32t control state. uint32t vbat. So what this does, this says, here's a field, unpack it with an uppercase V, and when you refer to it, use the name vbat flying percentage. It'll create a method that accesses that in the data. Here it says, unpack with a capital V, which is a 32-bit integer. Decode it with the decode float method, because we have to turn integers into floats. And then refer to it with the name theta. So essentially, I took the C header file, took out the semicolons, added a colon before each name, and now I got a Ruby program. This makes it trivial. I can decode any of those by just grabbing the C header file, a couple Emacs macros, and I'm ready to go. I can do that. So it makes it really, really easy to decode that binary data. I'm going to skip this one. That's not important. Here is a piece of code that uses that binary data. This is a callback that gets called every time we get a package of nav data. We ask, OK, are there any options in this nav data? And for each one, we loop through them, and I ask, is it nav data? Is it vision detection data here? And if it is, I said, well, did we detect anything? Well, if nothing, we're just going to hover. But if I detect something in the camera, I'm going to say, well, is it to the right of the camera field, or is it to the left of the camera field? Is it less than 400 or greater than 600? It's about 1,000 pixels, roughly, resolution. And if it's to the left, turn left. And if it's to the right, turn right. Otherwise, just sit there and hover. So the camera's facing the far wall. I have a target in my hand. I'm walking around to the far wall. Okay, can't move it fast. You got to move it slow enough so it stays in the field of vision. There we go. Okay, and that's it for that. We're out of time. I got a couple other videos if you want to catch me later and look at those. They're cool. My office mate Karen is doing some really interesting things with Clojure and drones as well. So we have Ruby drones and Clojure drones battling it off in our offices. Yeah, they're fun to play with. Ruby's fun. I have a lot of fun doing all kinds of things in Ruby. Ruby is an awesome language to learn. I encourage you to give it a try if you haven't. Thank you very much.